Hello friends, welcome back to Relief Tutorials. We have learned how to convert decimal into P by Q form. So we have seen type 1a. In this type you have seen that integral part is 0 and all decimal part has bar. So you have seen 0.m bar m upon 9. If 2 digit has bar, then mn upon 99. This is type 1a. Now type 1b we have seen the integral part is not 0 and all decimal part has a bar. So integral part not 0 and all decimal part has bar. All decimal part has a bar. So integral part is 0, integral part is not 0. All decimal part has bar and all decimal part has bar. This is type 1a and b. Now we will see type 2. Type 2a. So here in this we are going to see this type of type 0.mn bar. So integral part is 0 like this 0.mnp bar this, okay, or 0.mnp only one digit has bar. So moral of the story is that integral part is 0 and all decimal part has not bar. All decimal part has not bar. So now we will see type 2b. Here decimal part is not 0 like this way, see 2.35 bar, 23.52 bar, clear. So here see the type okay, integral part is not 0 and all decimal part has not bar. So moral of the story in both the cases, here integral part is 0, integral part 0, integral part 0, here integral part is not 0, integral part is not 0. Integral part is not 0. Have you got it? See, type to recognize the type, you should be able to differentiate it. Here integral part is 0 but all decimal part has not bar. Here integral part is not 0 and all decimal part has not bar. So all decimal part has not bar. Clear? So we have completed this type, type 1a and type 1b. Now we are going to do type 2a and type 2b. Clear? See. Now extra, you have to practice all this problem. It is not in your textbook. Extra. 0.32 bar. So here you see type 2a, integral part is not 0. Integral part is 0, sorry. And all decimal part has not bar. So what you will write to here? See, we can say here, see, how many digit does not has bar? This decimal should reach here. So it will become type 1, 2. This type 1, 2. See, this type of problem will become 2.3 bar. Clear? So here nothing you have to do. Just you will multiply. Now let x equals to, we can say this, let x equals to 0.32 bar. Multiply both sides by 10. Why? Only one digit has not bar. Clear? So if you multiply both the side by 10, so you will get 10x is equals to, you will multiply by 10, 3.2 bar. See, now this is type 1b. See, this type. So you have to convert type 2 into type 1. That's all, nothing else. Have you got it? Now you know 10x. Now 3 plus 0.2 bar. Got it, friends? Nothing you have to do, just you have to multiply so that this decimal will go here. 3.2 bar. So it will be of type 1b. Only one digit has no bar. So you multiply by 10. If 2 digit has no bar, you will multiply by 100. So now 10x is equals to 3 plus now 0.m bar. 0.m bar type 1a. See here 0.m bar type 1a. Clear? So you will write 2 upon 9. Are you able to cancel? No. So what you will take? 10x. LCM here 9. 9 3s are 27. 27 plus 2. 29. Now x we want, so this 10 is in multiplication, it will go here, division, so 29 upon 90. Got it? Clear? Okay. Now again one extra we will do. See, x is equals to 0.123 bar. See, integral part is 0 and all decimal part has not bar. So this, how many digit has no bar? 2 digits. So you multiply by 100, so it will go there. Clear? So now what we will write? Multiply both sides by 100. Why 100? Because 2 digit has no bar. So what you will get here? 100x is equals to this 100 means this will move 2 digits. So 12.3 bar. So 100x is equals to, now we will write 12 plus 0.3 bar. Now see this 0.m bar is equals to m upon 9. Clear? So you will write here 12 plus 3 upon 9, 100x. So 100x is equals to 12 plus 3 ones are 3s are 1 upon 3. So LCM here 3. 12 3s are 36 plus 1, 37. So 100x is equals to 37. So x is equals to 37 upon this 100 multiplication goes on division 300. Have you got it, friends? So this is the way you have to do this type of problem. Quite easy. Clear? Now again extra problem. See now. Let x is equals to 4.32 bar. Now this is type 2b. See, type 2b. Integral part is not 0 and all decimal part has no bar. That is type 2b. Clear? So how many digit has no bar? 1 digit. So you multiply by 10. Nothing. Just multiply both sides by 10. So what you will get here? 10x is equals to this 1 digit it will move. So 43.2 bar. So that all decimal part should have a bar. Why we are doing so? You should understand what is the reason behind it. Why we are multiplying with 10? So that decimal comes here and all decimal part has bar. Now this you will write 10x is equals to 43 plus 0.2 bar. So that will be 43 plus 0.2 bar means 2 upon 9. You know that 0.m bar is equals to m upon 9. Clear? So now 10x is equals to now LCM. You can't cancel this. 9. 43 9s are 43 into 9. 9 3s are 27. Carry 2. 9 4s are 36 and 2. 38. 387 plus 2. So 10x is equals to 389 upon 9. Clear? Now this 10 multiplication goes here. So x is equals to 389 upon 90. Got it? Now one more extra. Let x is equals to 15.712 bar. Okay, on 2 digit we'll put bar. Come on. So you know this decimal move should move here. After decimal only 1 digit has no bar. So multiply both sides by 10. So what you will get here? 10x is equals to 157.12 bar. So now again split 157 plus 0.12 bar. Now you know here type 0.mn bar. So that is equals to mn upon 99. Clear? So 10x is equals to 157 plus 12 upon 99. You can cancel with 3. So 157 plus 3 4s are 333s are. This is 10x. Clear? Now 10x equals to LCM we will put here. Clear? So what will be the LCM here? 33. You will multiply 33 with 157. So you will get 5181 plus here 4. So 10x is equals to 5185 upon 33. Clear? So now x. So x is equals to this 10 is in multiplication goes here division 5185 upon 330. Have you got it, friends? So with this we have learned how to convert decimal into P by Q form. I hope you have understood this. I will give little bit practice of this problem. Okay, so we have completed this type. So we have learned how to convert decimal into P by Q form. Clear? Now we'll come back to our exercise. So you know that we were doing exercise 1.3. See now, question number 4 we will do. Textbook. Question number 4, exercise 1.3. Clear? Now we have to express 0.999 ... in the form P by Q. In the form P by Q. Are you surprised by your answer? With your teacher and classmate discuss why the answer makes sense. We have to convert this. So we can write let x is equals to 0.9999 ... So that is equals to 0.9 bar. So you know it is type 1a. Integral part is 0 and all decimal part has a bar. 0.m bar. But now you will know only one digit has bar. So multiply both the sides by 10. This will take as 1. So what you will get? 10x is equals to 9.9999 ... This is 2. Now subtract 1 from 2. 10x minus x is equals to 9.999 ... minus 0.9999 ... 10x minus x, so you will get 9x. Now you know decimal part 0.999. Here also decimal part 0.999, so it will be 0. Now 9 minus 0 is equals to 9. So x is equals to 9 upon 9. So x is equals to 1. So 0.99999 we got 1. Why? What is the reason you can? Okay, are you surprised to get an integer answer as 1? Yes, because after decimal 9 is repeated infinitely. After decimal 9 is repeated infinitely, and you know this will tends to 1. So we can say 0.9999999 you can write many times infinitely. So that means it tends to 1. It tends to 1. Have you got it? So we are getting answer 1. So this we have done. Question number 4. Question number 5 we have already done. Now we will see question number 6. See what it says. Look at several examples of rational number in the form P by Q. Rational number in the form P by Q where P, Q belongs to Z, Q is not equals to 0 and P and Q are co-prime. This was our definition, if you know that, of rational number. They are co-primes. Okay. Can you guess what property Q must satisfy? What should be the property of Q? If P by Q have terminating decimal and P by Q have terminating decimal. So if P by Q have terminating decimal, explain property of Q. This you will learn in 10th standard as a theorem. Explain property of Q. Property of Q. You have to explain the property of Q. See now, solution we will see now. See, I will take few examples. Here. If I say, see numbers like let numbers be, see 1 by 2, 1 by 4, 5 by 8, clear? Then we can say 36 by 25, 19 by 20, etc. All these are P by Q. And they have terminating decimal, then you have to explain the property of Q. Now see 1 by 2. So I want in denominator I will make 10 power. That is 10 raised to n anyway. See 1 by 2, so I can multiply by 5. So 1 by 2, numerator by 5 and denominator by 5. This will get cancelled. So value will not change. 1 by 2. So that is equals to 5 by 10. 5 by 10. And you know 5 by 10 is equals to nothing, but it is 0.5. So it is terminating decimal. Now we have to see the pattern of denominator. Okay. Then we will see 1 by 4. So I can say here 1 by 4. So I will multiply by 25. Here also I can multiply by 25. So 25 by 100. 4 into 25. So answer will be 0.25. Then I will take 5 by 8. Okay, come on. So now 5 by 8 multiply. I want 100. So I will, or 1000. What will be 10 raised to n? So I will multiply by 125. 125. So 5 into 125 is 625 upon 8 into 125 is 1000. Clear? So that is equals to 0.625, or I can write this way also, 625 upon 10 raised to 3. Here 10 raised to 2, here 10 raised to 1. See, you see the denominator pattern. Now 36 upon 25. So I can write 36 into 4 upon 25 into 4. Clear? So 36 into 4 is 144 upon 25 into 4 is equals to 100. So that is 144 upon 10 raised to 2. You see. So answer will be 1.44. See, all these are terminating decimal, but you see the pattern of denominator cube. Have you got it? One more. See, 19 upon 20. So I can write here 19 upon 20 multiply by 5. So 19 5s are. So 19 5s are, we get 95 upon 20 into 5, 100. So that is equals to 95 upon 10 raised to 2. So 0.95. So if you look at the denominator here, see. So denominator here we can say denominator q. So here denominator, any example you can take, denominator q is in the form 10 raised to n. So that is equals to 10 raised to n means I can write 2 into 5, 10 raised to n. Clear? So I can say a denominator has two factor, 2 and 5. Then only we will get, see, 110, whatever may be 10 raised to n. So this 10 raised to n means I can write 2 into 5 raised to n. In short, I can say this denominator should has factor 2 and 5. Clear? So I can say denominator q is in the form, so therefore denominator q is in the form 2 raised to n, 5 raised to n. Power will be different. See, if you say 100, so if I write 100, say 100 means I can say 2 times 50, 2 times 25. Then 5s are. So 2 raised to 2 and 5 raised to 2. Okay, here power are same, but in some case power will be different. If you take 1000, see 2 times 500, 2 times 250, 2 times. Here also we will get 2 raised to 3 into 5 raised to 3. Why? Because 1000 means 10 cube. So you will write 2 into 5 raised to 3. So 2 raised to 3, 5 raised to 3. But it is not necessary that 2 and 5 should have the same power. Power may be different. Okay. Sometimes if denominator has 200, then 200 means 2 into 100. So that is because 2 into 100 means 10 square. So 2 into, you will get 2 into 5 raised to 2. So 2 into 2 square into 5 square. So you will get 2 cube into 5. 2 cube into 5 square. So power may be different. If denominator is 200, in that case also we may get terminating decimals. So moral of the story, this theorem you will learn in 10th standard, but one thing you have to remember, in order to get this terminating decimal, denominator q should be in the form 2 raised to n, 5 raised to m, where m and n are whole numbers. Whole numbers. Clear? Are you understanding? So nothing you have to say. What is the pattern? If p by q has terminating decimal, what is the pattern or property of q? So if p by q is terminating decimal, then denominator q is in the form, don't write this, okay? Denominator q is in the form 2 raised to n, 5 raised to m, where m and n are whole number. Clear? See, you take anything, 7 by 200, for example, see, 7 by 200. So by 2 you can say 3.5 times 2 and this 100 times. So answer will be 0.035. So this is terminating decimal or not. So 7 upon 200 is also terminating decimal. Now if you see the factor of 200, then what you will get? 2 times 100, 2 times 50, 2 times 25, 5 ones are. So denominator q is equals to 200 and that is equals to what you will get? 2 cube into 5 square. So always the power will not be the same in case of terminating decimal. So we can say denominator q is in the form 2 raised to m, 5 raised to n, where m and n are whole numbers. Clear? I hope you understood this question. Now question number 7. Exercise 1.3 textbook. Write number whose decimal expansion are non-terminating, non-recurring. So non-terminating, non-recurring. So I told you, if you know in the beginning of our lecture, 2 times non. So all non-terminating, non-recurring numbers are irrational numbers. You might be knowing that they are irrational numbers. Clear? Now you take any example. See, example you can take 0.10, 100, 100, 140, anything. This all are, see, non-terminating. It does not end and nothing is repeating here. Clear? So any number you can take 0.0020, 200, 200, anything you can take, or 0.1357894321468 3 ... See here, what happens here? Nothing is repeating. It is non-terminating and also non-recurring. So all these are irrational numbers. So you can take any example. Clear? So you can write any other number as per your choice. There is no specification. But what you have to consider it should be non-terminating and it should be non-recurring. Those numbers are called irrational number. Clear? So this is question number 7. Now we will see question number 8. Textbook, exercise 1.3. Find 3 different irrational numbers. 3 different irrational numbers between rational numbers. Between rational numbers 5 by 7 and 9 by 11. See, these are written in the form P by Q. So, it is a rational number. Okay. Some students even get confused, sir, whether this is a rational or irrational number. Array, it is written in the form P by Q means it is a rational. Irrational number cannot be written in the form P by Q. So, mere by observation only you can say, okay, sir, this number is written in the form P by Q. So, naturally it is a rational number. Clear? So, now we will write the decimal form of these two numbers. See, 5 by 7 and 0. So, I have explained you, if you know that. You divide 5 by 7. Otherwise, okay, see, I will divide 5 by 7. So, 0.0, 7 sevens are, what you will get? 49, 1, again 0, so 1 time, that is 7, so you will get 3, so 30, clear? 7 fours are, that is 28, again 2, 0, 20, 2 times, that is 14, 6, 60, 7 eights are, 7 eights are 56, again 4, 40, okay, so 7 fives are 35, then again you got 5, 0, 50, so again it will continue, see. Have you seen? This is 50, here 50, so same thing, this will be continued. So we can say now what is 5 by 7, clear? And now 9 by 11, clear? So this is 5 by 7 done, now 9 divided by 11, so 0.0, how many times? 8 times, 88, then 2, 20, how many times? 1 time, that is 11, then again 9, 0, 90, see here. So again 8, 1, 8, 1, clear? So now you can say 5 by 7 is equals to 0.7142, 714285, 714285, okay, so that I will write bar, okay, and 11 by and 9 by 11 is equals to 0.81 bar. So you got the value of these two numbers. Both are rational number, but they are not terminating decimal, they are non-terminating recurring decimal. Now you have to write three different irrational number between this. So three irrational numbers between 0.714285 bar and 0.81 bar. So 7 and 8, in between this you have to write the bar. 71 and 81. So what you can write? 0.71 and 81 means I can write 75. This is 71, this is 81. So 71 and 81, in between you come 75. 750, 7500, 75000, dot. Any number you can write according to your wish. 0.71 and 81, so I can write 77. 0.770, 7700, 77000, dash. Or again you can write 0.80, you can write in between 80. So 0.80, 800, 8000, 840, dot. Any number you can write, but it should be between 71 and 81. That's all. So these are the three irrational numbers. So first we have converted this rational number in the form P by Q into decimal form, and then we have selected any three number which lies between 0.71 and 0.81. So I hope you understood this question. Now you have to classify the following number as rational or irrational. Okay. Exercise 1.3 textbook, question number 9. So you have to classify this number. See, root 23. So 23 is not a perfect square. I told you if you had root m is a irrational number. Condition, this should not be a perfect square, that's all. So if m is not a perfect square, then it is a irrational number. Say 23, so we can say it is a irrational number. I have explained you if you know that. Now root 225. So root 225 means you know it is root 15 square. So the square and root will get cancelled. So 15. 15 is a rational number. Because 225 is a perfect square. It is a square of 15. Clear? Now 0.3796. See what type of decimal it is? It is terminating decimal. It is terminating decimal. So all terminating decimals are rational numbers. So therefore it is a rational number. It is a rational number. Clear? Now 7.478 dot. So you know this is 7.478 bar. So we can say it is non-terminating recurring. Non-terminating recurring. So therefore it is a rational. If you know that in the previous lecture I have told you all terminating decimal and all non-terminating recurring decimals are rational. Okay. Now see this 0.10, 100, 100, 140, dot. So what it is? So it is non-terminating, non-recurring. 2 times non. So if 2 times non, so if 2 times non appear, then you know that it is irrational number. It is irrational number. So all terminating decimal and non-terminating recurring decimals are rational number, and non-terminating non-recurring decimals are irrational numbers. Clear? So with this we have completed our exercise 1.3. Okay. Now see few things again I want to explain you. Now few notes. Note. So you know note 1. All terminating and non-terminating recurring decimals are rational. Note 2. All non-terminating, non-recurring decimals are irrational. Okay, this you are familiar. We have done many problems based on this. Now, note 3. See, if I say if A is equals to 3 and B is equals to root 2. So, this A is rational, B root 2 is irrational. So, sum of rational and irrational. Now, sum A plus or minus, what you will say, A plus B. So, that is equals to 3 plus or minus root 2. So, this number is irrational. So, moral of the story is sum or difference of rational and irrational. Sum or difference of, this is rational 3 and root 2 is irrational. So, sum or difference of rational and irrational is always irrational. Have you got it? So, this is note 3. Now, note 4. See, if A is equals to 3 and B is equals to root 2. See, this is rational, huh? This is rational. Q, this is rational Q, and this is irrational, IR, irrational. Now we can say, see, A into B, so that is equals to 3 into root 2. So, product of rational and irrational is always irrational. This is irrational. Clear? Or you can say A upon B, that is 3 upon root 2. So, both these numbers are irrational. Root 2 is irrational. You multiply that irrational number with 3, you will get irrational number. See, here I will say root 2 means approximately 1.414 it is going. You multiply this with 3. So, answer also will be non-terminating, non-recurring, irrational. So, what we can say, therefore, product means multiplication. See, product 3 into root 2 is irrational, 3 by root 2 is irrational, root 2 by 3 is also irrational. So, product or quotient means division. Product or quotient of rational and irrational is always irrational. Have you got it, friends? So, moral of the story is a sum or difference of one rational number and other irrational number. If you add or subtract these two numbers, answer will be rational. Now, if one is rational number, other is irrational number, then you multiply rational and irrational, or you divide rational and irrational, answer will be always irrational. So, product or quotient of rational and irrational is always irrational. See, all this thing is necessary even in 10th standard. The same chapter you are going to learn in 10th standard. So, please be aware. This is very important chapter. Have you got it now? Okay, now see. Now we will do exercise 1.5. Exercise 1.5 textbook, question number 1. Now classify following numbers are rational or irrational. So classify as rational or irrational. Okay. Say now. 2 minus root 5. So this is rational. This is irrational. So difference of rational and irrational is always irrational. Have you got it, friends? So now you are able to classify any number as rational or irrational. Now see, 3 plus root 23 minus root 23. This is first, this is second. So how you will write this? 3 plus root 23 minus root 23. So this 2 will get cancelled. So answer is 3. So it is a rational. 3 is a rational number. Clear? Third one. 2 root 7 upon 7 root 7. 7 root 7, sir. Root 7. So this root 7 cancels. So that is equals to 2 by 7. So therefore it is a P by Q form. So it is rational. One by root 2. This is rational. This is irrational. So it is irrational. Clear? So it is irrational. Now fifth one. 2 pi. 2 is rational. Pi is irrational. So product of rational and irrational is irrational. Have you got it? Clear? Okay. Now see, we will do question number 3. Exercise 1.5 textbook question number 3. Read the question. What it is? Recall pi is defined. Pi is defined as ratio. It is defined as ratio of circumference of a circle. Circumference means C of a circle to its diameter. To its diameter. That is D. Okay. Now this seems to contradict the fact that pi is an irrational. What it says is pi is a ratio of circumference C of a circle to its diameter C. So diameter D. So what it says pi is equals to, they are telling circumference C upon diameter D. So this is P by Q form. And diameter of a circle will never be equal to 0. So P by Q form means it should be rational. But we are saying that pi is irrational. So there is a contradiction. Are you getting? Okay, circumference of a circle, that 2 pi r. You know that? Circumference of a circle is 2 pi r and diameter of a circle, see this diameter of a circle, this is radius, this is also radius. So diameter of a circle is 2r. So r cancel, 2 cancel. So what you will get? Pi. So pi is a ratio of circumference and diameter. So it is in the form P by Q. So it should be rational. But pi is irrational. Why? Because you know that C by 2 is irrational. Reason is that we will get approximate value. If you find C by D, we will get the approximate rational value. Okay. So when you measure, when you divide, so we can say a reason, we can say what is the reason? C by D is an approx value. It is an approx value of pi. It is not real value, it is approx value of pi. So we are considering this as rational. But if you take accurate value of pi, then it is irrational. Accurate value of pi is irrational. Have you got? Now there is no confusion, no? So there is no contradiction. So therefore there is no contradiction. There is no contradiction. So C by D, this value of pi is approx value. So pi equal to C by D is an approx value of pi. So it is rational. So we are considering it rational. But accurate value of pi is irrational. Have you got it? So this we have done. Now we will discuss few formulas. See here. Some important formulas we will see. See first one, if I say root AB means product of A and B. So this I can write as root A into root B. So root AB is equals to root A into root B. Remember that. Second one. Root A upon B. So that is equals to root A upon root B. Clear? Now third one. See, root A plus root B into root A minus root B. So in polynomial we have seen, see, sum and difference. Root A plus root B, root A minus root B. A plus B, A minus B. Difference of two perfect squares. So what you will write here, you know that here difference of two perfect squares. So root A the whole square minus root B the whole square. So A plus B, A minus B. So x plus y, x minus y is equals to x square minus y square. So you know that root A the whole square means this root and this square will get cancelled. So what you will get here? A. This root and this square will get cancelled. So you will get B. So we can say root A plus root B into root A minus root B is equals to A minus B. Clear? Okay. Now, see, this is the case. A plus root B into A minus root B. So this is also x plus y, x minus y. So what you will write? X square, that is A square minus root B the whole square. So what you will get here? This cancels. So that is A square minus B. Have you got it, friends? Nothing. Difference of two perfect square. X plus y, x minus y. So x square. So A square. Root B square means B. That's all. Clear? Or same thing you can write. No, here. Root A plus B and root A minus B. So same thing. What you will write? X square minus y square. So what you will get? A minus B square. Clear? Now, fifth one. Root A plus root B the whole square. You know A plus B, x plus y the whole square. So you know that x plus y the whole square is equals to x square plus 2xy plus y square. This formula, you know that algebraic identity. Same thing here. So what you will write? Root A the whole square plus 2 into root A into root B plus root B the whole square. X square plus 2xy plus y square. So what you will get here? Square and root will get cancelled. So A plus 2 root A into root B. Root A into root B is root AB. We can write. Clear? So root AB plus root B square means B. If here it is minus, root A minus root B square. So you know your formula, x minus y the whole square. So you will get x square minus 2xy plus y square. Clear? So here you will get minus. That's all. If it is plus and minus, so you will get here plus sign minus, here plus sign minus. Have you got it? Now last, sixth one, see. Root A plus root B into root C plus root D. So you multiply these two first. So root A into root C. You write this way, root A into root C. Clear? Plus, this will multiply with C. Now this A with D. Now root A into root D plus root B into root C plus root B into root D. Clear? So now you know the formula, root A into root C. Yeah, root A into root B is equal to root AB. So here you will write root AC plus root AD plus root BC plus root BD. So root A into root C, root AC. Root A into root D, root AD. Root B into root C, root BC. Root B into root D, root BD. Clear? So these are few identities. I think you are familiar in lower standard also we have seen this identity. You can't consider this as an identity, but these are the few facts you have to keep in your mind. Clear? I hope you understood this. So with this I am going to complete my lecture. So please go through this. It is very important chapter. Thank you very much.